Hello, in this video, we will look at long divisions and synthetic division of polynomials. If we look at the graph given, we can see that there are zeros for this function f of x. So notice that there is a zero here, and there are also zeros over here. Looks like there's two of them there from the graph. But if we specifically pay attention to this point here, 2, 0, okay? This means that at x equal 2, there is a 0. It also means that x minus 2 is a factor of f of x. Okay? Because if you recall, if you have, okay, let's recall, if we have, let's say x squared plus 7x plus 12 equals 0, if we have this polynomial, okay, this polynomial can be factored. If we factor this, we'll get x plus 3 times x plus 4 equals 0. These are called your factors. And then we get x plus 3 equals 0, or x plus 4 equals 0. So x is equal to minus 3, or x is equal to minus 4. These are called your zeros. So from the 0, okay, from the 0, you can get factor, right? From zeros, we can get factors. And from factors, we can get polynomial, okay? From factors, we can get polynomial. Okay? So that's why I'm saying here that if you have a 0 at x equal 2, then you have x minus 2 is a factor. Okay? And that's the whole idea that we just went through there. Now, if we have a factor, it also tells us, okay, from here, if x minus 2 is a factor of f of x, if x minus 2, okay, is a factor of f of x, okay, then there exists a second degree polynomial let's call it q of x, okay, and we can say that f of x is now equal to x minus 2 times some other polynomial q of x, some other polynomial. Now, how did I know that it's a second degree polynomial? Okay. How do we know it's a second degree polynomial? And later on, I will probably create a video or briefly talk about that in this video. Well, we did have a video on end behavior. So you notice that this polynomial here rises to the right and falls to the left. So it has to be some odd degree polynomial. Okay. But also each one of these things here, okay, which we have 3 zeros here, we see 3 dots there. This one is kind of close to, so if there are 3 zeros, that will tell us something about the polynomial, okay? That will tell us something about a polynomial, or that will tell us the degree of the polynomial, okay? So we will talk about that later on or in a different video. Now, one way, okay, one way to find q of x, okay, is to use long division. So let's look at an example of that. Okay. Example. Suppose I said to divide the polynomial uh, 6x cubed minus 19x squared plus 16x minus 4, and I want to divide that by x minus 2. Okay. So to set up long division, what we do, we generally draw what I call the box. Okay. And your divisor goes here. And then we put the polynomial 6x cubed minus 19x squared plus 16x minus 4. So one of the things you will have to do is make sure that when you set a polynomial, that the powers are in descending order, right? There's no missing terms, okay? So we always want to make sure that there is no missing terms. And if there's missing terms, we have what is called space holders, okay? So that's something to keep in mind when you divide polynomials. Now, the first thing we're going to do, okay, we're going to have some scrap work as usual. We're going to take the first term from the dividend and the first term from the divisor. So 6x cubed divided by x, and that will give us 6x squared, okay? And I will write that 6x squared, let's see if we can get rid of these, above the x squared term. So we write that above the 19x squared. Okay. And what I'm going to do now is multiply this by everything here. So if we go ahead and we do that, 6x squared times x becomes 6x cubed. Okay, or maybe I should put that in the same color. 6x squared, so I'm multiplying this times this. Okay, that becomes 6x cubed minus 12x squared. And remember, we always have to subtract. So this is a plus sign here. We always change the sign. So this now becomes a minus and this becomes a plus. And if we combine, we get minus 19x squared plus 12x squared will give me minus 7x squared. And this will cancel with that, right? Plus 6x cubed minus 6x cubed becomes 0. And then we repeat the process again now, okay? Before you repeat, we can bring this down, plus 16x. You ask yourself again, what is minus 7x squared divided by x? And that is going to give me minus 7x. So over here we write minus 7x. And what we do, we now multiply the minus 7x by all of this. And if I multiply that, minus 7x times x becomes minus 7x squared. And minus 7x times minus 2 becomes plus 14x. Okay, don't forget, the signs always have to be changed to the opposite. And if you're wondering why we're doing that, if you review the video we have on division of polynomials that I've created, you will see I explain it in detail there. Okay. So if we combine plus 16x minus 14x, that becomes positive 2x. And the minus 7x squared and the plus 7x squared is 0. And now we bring down the minus 4. And I repeat the process again. Okay. If you repeat the process now, what is 2x now divided by x? And that will become plus 2. So we write plus 2 over here. And then what we're going to do, we distribute. So we distribute the positive 2 to everything here. And if I do that, I have 2, positive 2 times x becomes positive 2x. And positive 2 times negative 2 becomes negative 4. And don't forget, where the sign has to be changed. This here is a positive. So by changing the sign, this becomes a negative, and this becomes a positive. And now, if we combine, minus 4 plus 4 is 0, and this will cancel out with this. So this here is your remainder, because there's nothing else to bring down, okay? There's nothing else to bring down. So what we can see from long division, okay, we see from long division, 6x cubed minus 19x squared plus 16x minus 4 is the same as x minus 2 times our quotient, which is 6x squared minus 7x plus 2. Okay? Plus 2. Now notice that if we have x minus 2 times 6x squared minus 7x plus 2, this can be factored. And if we factor that, we will get 2x minus 1 times 3x minus 2. And if we bring this down, this becomes x minus 2. So these here are your factors, okay? Each one of this is a factor. So it's very important to see that if you know one of the zeros of the polynomial, you can find the resulting zeros. Okay? So as a quick reminder, if we have let's say x squared plus 3x plus 5. And if I divide that by x plus 1, and I do all of the work here, okay, you will see that x, so if we look at the scrap work, x squared divided by x is equal to x. So we write the x over there. And then this becomes, if I multiply x squared plus x. And then this was a plus. So then this sign becomes a minus, that becomes a minus. So we have 2x here. This will cancel out. And if we bring down the plus 5, and we repeat the process again, 2x divided by x, that is equal to 2. So here we write the plus 2. And then we multiply, so this becomes positive 2x plus 2, okay? And if we change the sign, this becomes a minus, that becomes a minus. So we have here a remainder of 3, okay? So the reminder here, the reminder that I want to talk about is this here, okay, is called your divisor. This is what we call the divisor. This up here, oops, this up here is what we call the quotient. And in here, okay, this is what we call the dividend, the dividend. And lastly, this here is what we call the remainder. Okay. The remainder. So we should know what the dividend is, we should know what the quotient is, and we should know what the divisor is when we talk about these things. Okay. And you will see very important, okay, that in general, if we have x cubed plus 3x plus 5 divided by, let's say, x plus 1, okay? This here, we got it red, this here is our dividend, okay? This is the dividend. And the denominator, which I had highlighted green, this is your divisor. Now, if you perform that long division, you will get an answer, okay? We didn't do this, x plus 2. This plus some remainder, you'll get a remainder, okay? This here should have been a square. That should have been a square. Plus 3 over the divisor, which is x plus 1. So here, we had highlighted that yellow. This is your quotient. Okay. And this is the remainder. And obviously this here was your divisor. So the remainder is always put over the divisor. That's one way of writing it. Now that brings us to what is called the division algorithm. Now you'll see that if we multiply both sides by x plus 1, okay, so this implies this here can also be written as x plus 2 times x plus 1 plus 3. Okay. And we get that by multiplying both terms by x plus 1. Okay. If we multiply both terms by x plus 1. And this is what's called the division algorithm. So what we just did there is called the division algorithm, right? If we have a function, then that function can be written as the divisor times the quotient plus the remainder. And obviously, sometimes the remainder will be 0. Okay? Sometimes the remainder will be 0. So let's look at an example. Let's look at an example. Let's divide. Okay. So let's divide 3x cubed minus 16x squared plus 5. So notice, okay, very important, star. Notice that we have missing terms in the numerator. When this is the case, we will use placeholders. So we can write this as 3x cubed minus 16x squared. So after a 3 power is a 2 power. After a 2 power comes a 1 power, which we don't have. So what we'll do, plus, always plus 0x. Okay. Now we have that 1 power there. Okay. Now we have the 1 power. And then we write our plus 5. So sometimes you're going to have to fill in more than one placeholders. Okay. And the same thing goes for the denominator. The denominator is okay because this is a 1 power and then you have constant. Okay. Now we can proceed. We can now proceed to use long division. So if we set it up the way we're setting up, okay, we have x minus 6 out here. I want to do that in black because we need the colors. The colors generally would just give you a good guide to what I'm doing. Okay. you'll be able to follow. So 3x cubed minus 16x squared plus 0x plus 5, and here we have x minus 6. And remember, we have some scrap work, right? Scrap. So the first thing, this and this, right? First terms. First term, this. So what is 3x cubed divided by x? And that will be 3x squared. Yeah. So we write our 3x squared above the x squared term. And then we distribute. So if we distribute, 3x squared times x becomes positive 3x cubed. And then 3x squared times minus 6 becomes minus 18x squared. Don't forget, we have to change the sign, so this becomes a minus, and this now becomes a plus. If we do that, minus 16x squared plus 18x squared becomes 2x squared. And then the plus 2x cubed and the minus 3x cubed cancels out. We will now bring down our plus 0x. Okay, we finish distributing, so I'll remove that. And we repeat the process again. What is 2x squared divided by x? And that becomes 2x. So we write plus 2x here. Okay, and don't forget, we have to now distribute everything by x minus 6 by 2x. So if we distribute, 2x times x becomes positive 2x squared, and 2x times minus 6 becomes minus 12x. Remember, the sign has to be changed, so that becomes a minus, that becomes a plus. So this becomes 12x, and then this will cancel out with this. And we now bring down the plus 5. Okay. So if we divide again, we have what is 12x divided by x, and that is equal to 12. So here we write plus 12. I want to get rid of this because we'll now distribute everything here. Okay. So 12 times x becomes plus 12x, and 12 times negative 6 becomes minus 72. Don't forget, we have to change our sign, so this is a minus, this becomes a plus. So 5 plus 72 becomes 77, and this cancels with that. And there's nothing else to bring down, okay? So this here is my remainder. Okay? This is my remainder. So what we can say here, right? What we can say is that 3x cubed minus 16x squared plus 5 divided by x minus 6 is the same as 3, let's put that in color, 3x squared plus 2x plus 12 plus the remainder 77 over the divisor x minus 6. Or we can say that this is the same as 3x squared plus 2x plus 12 times x minus 6 plus 77. Okay. Well, remember, this is my the quotient. This is the quotient, q of x. This is the divisor, d of x. and this is the remainder R of X. Okay. And that's the division algorithm that we were talking about here. They use lowercase r, so let's use lowercase r also. Okay. So this is times, that's plus. So long division we have seen before. Now we're just putting it in some form of a special way of writing. Now, as you can see, this is called long division, right? And here's why. The steps, it takes a lot of steps and it's very detailed. And it can very easily make mistake with the signs, changing the signs and so on. Well, fortunately for us, there is a shortcut. Okay? For long divisions of polynomials, where the divisor is linear. So that's the only problem. You can only use the shortcut if the divisor is linear. Okay? So there is a shortcut. So let's make a note of that. There is a shortcut. There is a shortcut for long division, but there's a big but. It only works when, or if, I should say, if the divisor is linear. So that means this means the divisor is in the form x minus, let's say, k. Okay, x minus k. And this is called the shortcut. The shortcut we're referring to is called synthetic division. Synthetic division. This is the shortcut. Okay. So in synthetic division, what we do, we just use the coefficients of the polynomial. Okay. We use the coefficient of the polynomial. So let's say we have, let's look at this. Okay. To divide, let's say ax cubed plus bx squared plus cx plus d by x minus k. Okay. So what we do here, notice how we draw the box now, right? The box is drawn this way. Okay. Actually, I don't need to make it that big. Let's do it this way. Oops. Now pay attention here. On the outside of the box, okay, k. So notice we don't use minus k, we just use the solution. Okay, so if we have x minus k is equal to 0, then x is equal to k, right? This is what we will use. Okay, now on the inside here, we will use the coefficient a plus b, and we take the signs with them, right? C, and then plus d. So if it's a negative, we have to put the negative there. And we start out by bringing down the a. Okay. We start out by bringing down the a. And whatever is left over here, this is your remainder. So this is the pattern we'll use. This is the pattern. It may look confusing, but it's not. You will see in a minute that it's not very confusing at all. Okay, not very confusing. So let's look at an example, because in math, example always bring things out to us. Example. So let's now use synthetic division. So remember, you cannot always use synthetic, right? We cannot always use synthetic division. And let's say we have x to the fourth, okay, minus 10x squared minus 2x plus 4 divided by x plus 3. So remember, to use synthetic, this has to be linear. So we can use synthetic division because the divisor is linear. Yeah, the divisor is linear. So this is what tells us if we can use synthetic division. Now your divisor, x plus 3. Now if we take x plus 3, so this is linear. Okay? If we take x plus 3 and we set it equal to 0, we get x is equal to minus 3. So this is the k that we're referring to. So if we set this up, if we set it up, okay, here we'll put minus 3. Now likewise, okay, notice that there is a missing term, 4. You head straight to 2 power, okay? So we're gonna have here the coefficient 1, then the coefficient 0, okay? This is our placeholder. Then we have a minus 10. Then we have a minus 2, and then we have a minus 4. So it's very important we have missing term here, right? Missing x cubed term. Yeah. So let's do this. So the first thing we do, we bring down the 1. Okay, always, that first term always comes down. And then we're gonna multiply we're gonna multiply negative 3 times 1. And negative 3 times 1 becomes negative 3. So we write negative 3 here. And you always add, always add. So if we add here, okay, this becomes negative 3. Okay. And then we multiply again. We're going to multiply now this times this. Negative 3 times negative 3 becomes positive 9. So this here becomes positive 9. And don't forget, we always add. So minus 10 plus 9 becomes negative 1. And we multiply again. Negative 1 times negative 3 becomes positive 3. Okay. And we add again. We always add. Negative 2 plus 3, that becomes positive 1. And we multiply again. 1 times negative 3 becomes negative 3. Okay. I believe that was a positive 4. No, that was a negative. Okay. And negative 4, we always add. This becomes negative 7. So this here, or I can put it in the same color. This here is my remainder. Okay, that's my remainder. So the quotient, this here is my quotient. So the quotient is, be careful, 1, okay, x cube. Then we have minus 3 x squared. Then we have minus 1 x. Okay. Plus 1, and plus, always plus the remainder, which is minus 7 over x plus 3. Okay. Now the question is, look at what I'm doing here. Notice here the degree of the polynomial is 4. Because every time you perform synthetic division, the degree will drop by 1. Okay. The degree decreases by 1. And that's how I know that this here will be an x cube. Okay? That's how I know that that's an x cube term. So let's look at another example, and hopefully this becomes a little bit better for you or clear. So if we look at this example here, and we want to use synthetic division again, notice that we don't have any missing terms, right? 4 power, 3 power, 2 power, 1 power, then no power, right? Constant term. And this is linear, so which is very important. This is linear. Okay, so we can use synthetic division, right? Remember, the goal is that to use synthetic division, that has to be linear. So then here we put 2. How are we getting 2? Because x minus 2 equals 0, so x is equal to 2. Okay, 2. It has to be the solution. And here we use the coefficient 2, positive 7, minus 4, minus 27, minus 18. And let's do it now. So the first step is to bring down the 2, and then we multiply. Okay, we multiply 2 times 2, and that will become 4. And we add 7 plus 4, that is 11. And then 2 times 11, that becomes 22. And if we add, this now becomes 18. Okay. And then we multiply again, 18 times 2, that becomes 36. And then we add negative 27 plus 36, that becomes 9. And then 2 times 9 is 18. We multiply again. 2 times 9 is 18. And then if we add, we get 0. So this is your remainder. So what we know, okay, we can say that this here is 2. Remember, this here was 4 degree. The degree was 4, okay? The degree here is 4. So this becomes x cubed, okay? So x cubed plus 11x squared plus 18x plus 9, okay? This is our answer, or the quotient, okay? So 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18 divided by x minus 2. This is equal to 2x cubed plus 11x squared plus 18x plus 9. Now, notice that the remainder and factor theorem, right? If a polynomial f of x is divided by x minus k, then the remainder, r, is f of k. So what does that really tell? What does this really tells us? Well, notice that here my remainder is 0, okay? And this is telling us, right? This means if you have, okay, this problem we had 2x to the 4, f of x is equal to 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18, okay? And we were dividing this by x minus 2, right? X minus 2. And we did get a remainder of 0. The remainder here is 0. Now, if you find f of our divisor here was 2, okay? What is f of 2? F of 2 would be 2, and then here we have 2 to the 4th power plus 7, okay, times 2 to the 3rd power minus 4 times 2 to the 2nd power, okay, minus 27 times 2, and minus 18. So if we simplify this, 2 to the 4th becomes 16 plus 7, this becomes 8 minus 4, 4 minus 27 times 2 minus 18. So 2 times 16 is 32, 7 times 8, 56, minus 4 times 4 becomes minus 16, 27 times 2 is 54, minus 18, okay? Now, if you combine these, right? If you combine these, 32 plus 56, this becomes 88. minus 16, minus 54, minus 18. If you combine these two, this becomes 72, minus 54, minus 18. If you combine these two, this becomes 18 minus 18. So f of 2 is equal to 0. And notice that you had 0 was also a remainder, or d was also the remainder. And that's what this is telling us. That's what this here means. That the remainder is the same as if you take f of what you're using the value, the k, for synthetic division, this k value here. That's basically what it's telling us. Yeah. So you will notice that if we perform any long division, right, you will notice that. Okay. Let's look at an example. Okay. Use synthetic. So if we have f of x is equal to 3x cubed plus 8x squared plus 5x minus 7. Okay. And let's divide f of x by x plus 2. So notice that this is linear. Okay. So if we set this up, we have minus 2 here because x plus 2 is equal to 0, so x is equal to minus 2. This is our k. Then 3 power, 2 power, 1 power constant, so we don't have any missing terms. So here we can have a 3, a 8, a 5, and a minus 7. Don't forget we always bring down. And then we multiply these two things. So this becomes negative 6. We add, we'll get 2. We multiply again, multiply this with this. So that becomes negative 4. We add, we have a 1. And then we multiply again this times this, and that becomes negative 2. And if we add, we get negative 9. So this here is my remainder. But what I want to show you is that if we say f of negative 2, this is going to be equal to negative 9. Okay? F of negative 2 is going to be equal to negative 9. And we can try it. Okay? Let's see if this is true. So f of x was given to us as 3x cubed plus 8x squared plus 5x minus 7. So what is f of negative 2? It will be 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. So this becomes 3. Negative 2 cubed will give me negative 8 plus 8 times negative 2 squared was 4 plus 5 times negative 2 minus 7. All this becomes minus 24 plus 32 minus 10 minus 7. And if I combine these two, okay, if I combine those two, minus 24 plus 32 is positive 8. Minus 10 minus 7, if I combine these two, okay, this becomes minus 2. And then here I get negative 9. So f of minus 2 is -9. So it does work. Okay? It does work. And that's something you will see always. It will work. Okay? And the last thing we want to talk about is the factor theorem, right? What does it tell us? It tells us that if the factor is used in syntactic division and we get, okay, and we get a remainder of 0, then it is confirmed that it is a factor. So let's look at this. If we want to show that x plus 3, which is a factor, right, is a factor of f of x. So we have no missing terms here. 4 power, 3 power, 2 power, 1 power, constant term. If we perform synthetic division, okay, remember since x plus 3 is a factor, then k would be minus 3. And you'll notice that you'll get 0 here. So since we get 0, this tells that x plus 3 is an actual factor. So there's a lot of things happening. Not only are we learning how to use synthetic division, but we're seeing certain things that will help us, right? And that's the key point. So the whole idea here is that we will use this to help us find zeros of the polynomial or additional zeros. So it's very important that you master this synthetic division. Well, keep in mind, you also have to know long division, because if the divisor is not linear, we cannot use synthetic division. Okay? So hopefully you can practice some more problems. As always, the practice will help you to become better at this. And I'll see you in the next video.